Hello everyone, my name is Kaushik.
And my name is Jahnavi, and today Kaushik and I are going to present about computer architecture. So first, what is a computer? A computer is a machine that processes information. All computers need some way of inputting, outputting, storing, and processing information. Computers were originally known as people who compute or do math. I know you all are very proficient in math, so this title would be fitting.
So I'm going to talk about the differences between hardware and software. Hardware is physical, which means that you can break it. And because it's physical, it means that it's limited to the physical world. You could, in an example would be that you could, in theory, build a computer that flies in the sky, but it wouldn't be practical. Another thing with it being physical is that it's rigid and replaceable. So if you want to upgrade your hardware, you can. Software, however, is abstract, which means that it's based off of code. It's flexible and updatable, unlike hardware. An example would be if a manufacturer or a company designs a product and they realize that they designed it with a problem. They can't just go to every person that bought it and fix it. While with the software, they can just fix it in what's known as a software update. Another thing with software is that even though it's very flexible, it's constrained to the limits of a computer, which means that if I have a software that needs a very powerful computer and I don't have a powerful computer, I can't run it.
Here are some milestones in computer engineering. In 1947, there was the invention of the transistor. A transistor is a switch. The significance of the invention of the transistor is that the transistor became a building block to create a computer. In 1958, it was the invention of the integrated circuit. The integrated circuit is a small computer chip. In 1971, Intel produced the first microprocessor. A microprocessor is a very small computer. It had about the 2,300 transistors on a single chip. Today, however, we have about 100 billion. And to continue, in 1974, there was the first true personal computer, the Altair 8800. Altair was the first actual PC. It was based on the 8-bit Intel 8080 microprocessor. Next, we have number systems. Number systems are used to represent very large or very small numbers. We have kilo to represent 1,000, mega to represent 1,000,000, giga to represent 1 billion, and so on and so forth. On the other side, we have milli to represent 1/1000, micro to represent 1/1,000,000th, and nano to represent 1/1 billion, and so on and so forth. In our daily lives, we use kilo and milli and other examples every day. Instead of saying 2,000 grams of something, we say 2 kilograms. And instead of saying instead of saying 0.5 liters, we sometimes say 500 milliliters.
So some commonly used units in computer science are bits, bytes, hertz, and a second. A bit is a one or a zero, and it is a fundamental concept in computer science. A byte BYTE consists of 8 bits. And 4 bits is considered a chomp. 3 bits is considered a nibble. A hertz is a unit of measurement that entitles cycles per second, or how fast something spins per second. And the most common measurement for time in computer science is seconds. So, a key consideration when it comes to computer architecture and why computer architecture is such a major field is it's not only just building a computer. Computer architecture entitles optimizing the design of a computer so that the data and the instructions can flow to the CPU easier for processing and then back to the memory. We do need a fast CPU, that is true. And we do need to be able to move the data around quickly, but it's not enough to have a super fast CPU or a super fast memory. The whole system or architecture must be designed to optimize instruction and data delivery to the CPU efficiently, because the CPU needs to process the data and send it back.